Okay, our next speaker is Ed Naris. Ed is a Massachusetts DOT pavement management engineer. He's been with the DOT for 27 years, 26 of which have been in various pavement design and pavement management roles. Ed's daily responsibilities include oversight of the pavement management program, project and treatment selection of preservation work, drafting specifications for him. He is also closely involved with the Mass DOT pavement research activities. Ed?
Thank you. All right, most of you will notice that my title is not the same as it is in the program. Really, we were going to talk about our experience with SHRP2. So that's pretty much what my presentation's about. It does involve UTBOs and fog seals, so kind of good with that. All right, just to give people an overview, how many of you are familiar with SHRP2 R26? Well, that's a high percentage. All right, so basically it was part of the Strategic Highway Research Program, the second part. And there were 4 broad areas of emphasis under SHRP2. There was highway safety, there was renewal, there was reliability, and there was capacity. And this came in, R26 was part of obviously the renewal. It's pavement preservation for high volume roadways. And I got involved when I was invited to a meeting to talk about this. And the DOT asked me to identify some preservation projects. And I love preservation, but the first thing I said was, oh, you know, by the time we do all the environmental work and the stormwater work and the bridge water work, you know, there's very little money left over for preservation. So the environmental director said to me, Ed, we can probably waive it for a project. What were you thinking? And I said, you know, maybe a couple miles here or there. Well, I got the waiver, so we went from 2 miles to 20, because we hate to let a good waiver go to waste. So these are the basic preservation treatments for high volume roadways. It's a pretty comprehensive list, but we kind of focused on 3 of the treatments, and one of the treatments we used 3 times. So, you know, we spec'd crack sealing, we spec'd 3 different types of ultra-thin bonded overlays, and then we specified profile milling. And that seemed to be a pretty good, selection of options. So how do we actually pick our projects, or how did this project come along? Well, we basically use a path runner automated vehicle for collecting pavement condition. And basically, we end up with a report that shows our, you know, it's the condition, it's the video of the roadway, and there's a distress map. And we use the distress in our project selection matrix, where different distresses relate to different treatments. And you can see that UTBOs were pretty good candidates. They fell within the condition ratings that we needed for that type of work. So the project we ended up picking was not a 2-mile section, but a 20.6-mile section of Route 3 North. It went from I-95 to the New Hampshire state line, so it's a major roadway for us. As far as high traffic volumes go, it was about 105,000 vehicles per day. And it was an interesting project because it was an ideal candidate for preservation. As you could see from the pictures, and you'll see more, there was light cracking and early raveling. We were losing some stones from the surface. There was end-to-load segregation from the prior work, and it really needed a treatment, and we had average ruts of about 0.2 of an inch. So we thought we could use a UTBO on it pretty safely without a lot of issues, without leveling, without a whole lot of milling. So here were our demonstration treatments. Since we had about 20 miles of roadway, we thought we could, you know, try a few different types of UTBOs. So we were a green DOT, so we were trying to put a green spin on some of this. So we decided to try a conventional 6428, and then as kind of a conventional technology, and then we decided to use an asphalt rubber UTBO, which is a recycled technology. And then we decided to use a 64V28, which is the new grading system, so polymer modified. We thought this would be a good way to compare how binders are impacting the different thin overlays. Now, what was interesting about this project is it's 3 travel lanes in each direction, but it was widened about a decade ago. So there was a full breakdown lane and a full high-speed shoulder, and all the bridges were widened for even an additional lane. So we had over 400,000 square yards of shoulders. And we thought that's an opportunity to try something different. You know, it's easy to ignore the shoulders, but you know, there's a lot of square yardage, and it seemed there's some pretty good treatment options for shoulders too. So we decided to try some fog seals. And so, you know, since it's a demo project, we figured, hey, let's try a few. There was a question, should we go with rejuvenators or the asphalt emulsions? And we said, well, let's try both. So one of the rejuvenators was reclamite. It was a pretty common, one of the more common rejuvenating seals out there. And we had an opportunity to place another one. It kind of came around at the last minute. It was a green chemistry rejuvenator called Delta S. They were around downstairs. And then we tried the fog seals for the high-speed shoulder. And we tried 3 different fog seals, a CRS2, which is just a conventional kind of fog seal, not modified, a gilsonite, which is a GSB 88, and a CRS2 PD, so it was just a polymer modified fog. And then we were looking at the shoulders and said, what are we going to do for friction, and do we need friction? Well, we wanted to look at different friction treatments as well. So we decided to use a high velocity shot blasting, and we also decided to try boiler slag. So we have a lot of different treatments going on, and we have different surface textures. So all of this started getting a little confusing. So we put together just a chart, and you can see, so that's the 20-mile roadway. Segment 3, which is the conventional HMA, was the northerly 7 miles. The middle 7 miles were the asphalt rubber, UTBO, and the middle and the most southerly section was the polymer modified. So we got a lot of questions when we put this out. They said, oh, what is this? You know, have we ever used it before? No, we're going to do 20 miles worth of something that we've never seen before. That would be a really good idea. The UTBO, we had a few years of experience, but we explained to people that you need to use a spray paver. It's a standard HMA. It comes out of a hot mix asphalt plant, but it's a little different because it's gap graded. It gives a bond coat, a really heavy tack coat, room to move around, room to migrate into the mix. And then I started talking to a few contractors, and we started getting some concerns, like, oh, what are you going to use? You're going to use that 1/2 inch? You're going to use the 3/8? Oh, if you use the 3/8, we have to double screen it. It's going to cost you a lot more money. I don't want to do it. And then we kind of looked at the gradations, and we determined that we were going to try and do a kind of a hybrid 3/8. So it's a finer 1/2 inch. Is that a hybrid 3/8 or a hybrid 1/2 inch? Basically, we were between a 1/2 inch and a 3/8 gradation. We also omitted the ramps just for money savings and speed of construction. And we also determined that this should be a QA spec, a quality assurance-based specification, because Federal Highway was involved, and they thought that was a good idea, and they were paying, so we thought it was a good idea. So we modified the specifications a little So we modified our ride quality specification to make it a little bit more reasonable for a 5/8 or a 3/4 inch overlay. We didn't think you can get the same ride quality from a 5/8 inch overlay as you can from a 2-inch mill and fill. So didn't have a whole lot of experience for what that number should be. So we how do you say, we winged it? We wung it? We wung it. So here's the roadway, and here's some of the things that were different. If you can see along the sides, we shimmed the shoulders to keep, so we could zero out at the fog line. I don't know if you guys can see that, but that meant we didn't have to replace the rumble strips, and we had a nice smooth transition from the UTBO to the shoulder. We thought that was important for us because we have a lot of plowing operations some years, 100 inches of snow. I didn't want to see any delamination or see the edges come up, so we thought that would be a nice smooth transition. We also specified a 7-foot milling machine because we didn't want to see someone come in with a trimmer. We thought the edge milling would also help with the slight rutting that was there. When we put the contract out, we didn't have a really good detail for how to transition into the ramps without a lot of handwork, which with ultra-thin bonded overlays sometimes doesn't look that great. So we worked with the contractor to develop just a kind of a detail, and you can see it here where we transition milled the turning lane, and then a few hundred feet of kind of the ramp. So this allowed the paving contractor to pull this pass and then come in and pull this pass, and it worked out really well. How many of you have seen a spray paver before? All right, well then you know what this is. It's a spray paver. You can obviously see the tack that's sprayed down, the HMA. We like this. We liked how it held up. We liked how it worked. We liked that there was no tracking at all. And tracking has become a huge issue in the state. And I've had a few people ask me, well, why can't we use those on everything? It's a different conversation. It's just, I borrowed this slide. It gives you a better idea of where the bond coat migrates on a UTBO overlay. And so I did want to talk about the shoulder treatments a little bit. Obviously, we've all seen the pictures. When we widened the roadway, it just created an awful lot of surface area. We didn't think the project would look complete if we didn't do something to the shoulders. So the fog seals were our choice. A fog seal, and I think everyone here knows, it's just a light application of a dilute asphalt emulsion to seal the existing surface. It's definitely a top-of-the-curve treatment, sprayed at 0.06 to 0.2 gallons a square yard, depending on what your surface is. And from our perspective, it was one of the most cost-effective preservation treatments, to the point at which I don't think fog seals are appropriate for all roadways. We thought this is a good start to see where we could use it. It's a very cost-effective treatment, but we did have to look at some. We did have to look at some of the challenges. I did want to mention the other fog seal that we used, the rejuvenating fog seal. Rejuvenators are oils that soften the existing binder and reduce its viscosity. This improves the flexibility of the binder. It reduces raveling and future loss of aggregate. We believe it replaces the maltines in the asphalt, and the dosage rate is something that's a little bit up in the air. We based our dosage rate on some field testing that we did, we tried to achieve a certain percentage of improvement in the viscosity. One of our considerations with fog seals, and that's why I kind of said, I think you have to be careful where you spray them, is fog seals and rejuvenating seals can reduce short-term pavement friction in the short term. So if you've got a friction problem, you don't want to be using a fog seal. We didn't believe we had a friction problem, but we still went to great lengths to make sure that we would have this covered. And we addressed it with both high velocity shot blasting, and we had Skidabrator up in New England to do some high velocity shot blasting. And we also used boiler slag on some of the control sections. We used Black Beauty. We also required skid testing in the contract, and we've done follow-up skid testing to see how it's holding up. This is a picture of the Skidabrator. I have a video of the Skidabrator, but it keeps crashing my presentation, so we won't be watching it today. It's pretty much a self-contained truck and trailer assembly that does the high velocity shot blasting on a segment about 6 feet wide. It shoots the shot, it collects the shot, and it vacuums the road, and it recycles the shot, and has all the waste in the trailer and back. So it's a great piece of equipment. We were impressed, and we were able to get the skid improvement that we were looking for with the unit traveling at about 2 miles an hour. People could not believe how quickly the process went. This photo shows the change in surface texture from the Skidabrator. You can see on the right was the existing pavement, and on the left was the Skidabrated pavement. So you can see all the little holes and all the abrasions, and it provided over a 20% improvement in skid value, which Dynatest came up to do friction testing. And here's the original data. Now this was done with a smooth tire. We've been testing with a rib tire. I know they're different tests, but that's kind of what worked out on this. So we started out with the skid number beforehand was 59. After the Skidabrator came through, it was 73. And then after the treatment, it did drop to 43. 4 hours after the treatment, it was 36. And the right travel lane that was an actual travel lane was at 47. So a lot of these skid numbers were actually higher because it was the travel lane and there was no kind of polishing of the aggregate. So we did lose some friction. It did come back. Okay, so after we Skidabrated, and because it was a QC job, we asked them to verify that they were getting the surface texture that they were looking for. So we didn't require a skid tester to come out every night to verify the work because that's a lot of time, a lot of money. We found out that we could actually use a surface friction outflow meter, to calculate surface friction. And basically, how many of you seen an outflow meter? What it basically, it's a device that has a known quantity of water and a timer, and when you open up the valve, it releases the water, and the texture of the surface will let more or less water out. So we were looking for a certain improvement in outflow, and it seemed to relate to some degree to the openness. So that was a good way to QC the high velocity shot blasting. Okay, so shooting the rejuvenating seal was interesting. did have a few comments on the pink color, Colin. It was sprayed at a rate that was, Colin, do you remember the rate offhand?
It's between 600 to 700 of a gallon per square yard.
Okay, between 600ths and 700ths of a gallon per square yard. We had testing performed before and after to see what the change in viscosity was. You can see the viscosity went from 28,000 to treated from 21,000 and to 32,000 from 59,000 poise. And the phase angle increased, so there was definitely softening going on. We also fog sealed the high-speed shoulder. Half the fog seal was on a skid abraded surface, and half the fog seal was with Black Beauty. The fog seal obviously adds asphalt to the pavement surface, so it seals and waterproofs. It retards future oxidation, makes the roadway look finished, and I'm not going to say that enough times. On high-speed roadways, exercise care to retain friction and safety. I know that we did. I just can't say that enough. So here's a mid-project photo. Northbound is completed. Southbound, only the main line had been completed. So you can kind of see how there's a definite visual improvement, and the fog line, the lines really stand out. We didn't allow them to do any striping until they were 100% completed with the fog seals. We didn't want them impacting the reflectivity or the visibility of the striping. All right, so what else did we do? Obviously, it's a research project, so we're monitoring condition, ride, and skid. It was also a pilot project for wet reflective pavement markings. And we used these slotted pavement markings that weren't really holding up, and we took this opportunity to do a pilot project with Federal Highways approval. So in one barrel, we used wet reflective polyurea, and in the other barrel, we used wet reflective thermo. By wet reflective, we used a different element that has improved visibility during wet weather. They're also recessed, and it's something we didn't do on a lot of our projects, but we had a requirement to come up with for the contractor to come in and do dry and wet reflective testing on the striping, and it was definitely something that it was a good thing to have done, because I think a lot of the projects when they go out, you don't get the visibility on the striping. This was one of the first jobs where we had required testing, we had a required testing frequency, and if the contractor couldn't meet the retroreflectivity requirements, we told him what he had to do about it, and he didn't want to have to do the striping over, so it put a nice finish on the roadway. All right, since we're a green DOT, I have to use this sustainability slide. As all of you know, sustainability is a three-legged stool. There's economic sustainability, environmental sustainability, and social sustainability. We wanted to show people that you can be sustainable and cost-effective. So when we looked at this project, it's 21 miles. Bid price was $8 million, all in with traffic control and everything. We were into it for about $9 million. As a mill and overlay, that would have probably been in the 30 mil range. Obviously, we would have gotten a few more years of service life, but one thing that was really unique about this project is I think there was 45, Alan, how many paving days? 47 paving days. The traveling public was absolutely impressed with how quickly the project went. So economically, it worked. Environmentally, we ran some CO2 and some emissions numbers and some energy usage numbers. And we were looking at a 62 to 64% reduction in energy and CO2. That's annualized. I don't remember what manual I used to calculate it. I know I got it through one of these conferences. The good thing about saving money and reducing the emissions is obviously you have the ability to reallocate your savings to other areas. And we also believe that, by using sustainable materials in the fog seals, that's an environmentally sustainable thing too. But now you're seeing why I don't like this slide, because it's a little too touchy-feely for me. There were also a lot of ride quality improvements. Part of the reason why we went with a hybrid 3/4 inch, a half-inch mixed design was because we had done some sound testing, and the 3/8 inch was a little quieter, but that we felt the half-inch was held up better. So when we went with the hybrid 3/8 half-inch, we felt it would give us a little bit of a quieter surface. People have commented that it seems quieter than what was there. And of course, we had some pretty good safety improvements, because even though the average rut depth was 2/10 of an inch, there were a few areas that were around 3/4 that we helped take out with the shim milling. When you're doing pavement preservation, you can't forget the details. Little things can make a big improvement. When Route 3 was previously constructed or widened, it was a design-build project, and let's just say there was some settlement on the bridge approaches. So when we were putting the project together, I talked to the project designer and I said, "Hey, Cody, let's fix some of these bridge approaches because there's a lot of settlement." He said, "I got to go back to the office and kind of figure out which ones." And Cody's an avid motorcyclist, and he said, "We should do these 3." And I said, "Why?" He said, "Because I can catch air on them." Like, all right, that's not very scientific, but all right, let's start with 3. We ended up doing 4. We actually did some profile milling, and the first thing we did is we went and we surveyed all of the bridge approaches that we were going to reprofile. Sent the survey data off to a designer who basically redesigned a new profile. Then we milled, we surveyed again, we paved, and we paved in some places in 2 lifts. And these are just some of the marks. So we had some 1 3/4 leveling. Here's some 2 inch, here's some 2 1/4, and here we were at 3.5 inches. So the bridge approaches had settled by about 3.5 inches at the worst locations. Just by straightening those out, we got so many comments from people. They're like, it's like a new road. So don't forget the details, because sometimes the little details matter. Here's just a photo of all the survey points, and after they paved the whole thing, they went and keyed it, and that's how we've had such a dramatic improvement in ride quality. So when we put this project out, one of the concerns was, are we going to be able to hit the ride spec? And so, it's a demo project, so we decided to look into it a little bit more than we ordinarily would. So before and after the UTBO, we measured the ride quality. And this is for the control strip, which was about 7 miles. Before the UTBO, the left lane was 84. After the UTBO, it was 55 inches per mile. So there was a dramatic increase in IRI. Now, what's not in here is that 84 is a micro-milled surface. So it didn't really matter if we were looking at a micro-milled surface or an unmilled surface. We still got numbers on the control strip of about 54 to 55. So that made us pretty comfortable with knowing we could hit the ride numbers. And we also kind of thought that 54, 55 number would be a pretty good target. Okay, so this was a QC job, so we looked at a lot of different factors, and we looked at the average bond code application rate. We had a couple little issues when we were placing the bond code, because the specification said 0.18 to 0.22 gallons per square yard. So we went to a meeting, and we said, it's a fairly tight surface, we want 0.18 gallons per square yard. After I left the meeting, the resident engineer said, I want 0.20 gallons per square yard because I want it right in the middle of the range. Sometimes you're better off not attending the meetings because it's frustrating when they don't listen. But we talked to the contractor again. The resident engineer agreed to do 0.18, and I think that was the right dosage. That was the right application for that roadway. But we'll see a little bit more on that later. Okay, so the project was subject to a 5% bonus, an incentive for good ride quality and binder content. Those were the only two things we looked at on this project. So this is just for one segment. Our target ride quality was 65 inches per mile. That's about 10 inches per mile higher than we would have on a conventional HMA overlay. The upper specification limit was 85, and the upper engineering limit was 100. So basically, anything over 100 would have been rejected. That was pretty conservative, but as a demo project, we didn't want to have overly high bids. You can take a look over here that the average IRI was between 51 and 53 for the whole 7-mile segment. The percent within limits was 100. All right, now somebody was going to ask me that they didn't like to do PWL analysis. They got full bonus on this for ride quality. Yeah, I see you back there smiling. So we were really impressed with what you could achieve for ride quality. I do have to commend All States Asphalt for the work they did, because I think they were really looking for that bonus, and they earned it. We also looked at the binder content from a QC standpoint. The target was 5.8. Oh, I'm sorry, it was 4.8. On this particular segment, it was 100 PWL, so they hit the full bonus for the binder content. On the asphalt rubber, they were only 92% within limits, so it was, instead of the full payment bonus, it was only 1.1 or 1.01, so it was a little lower. I'm not sure if that's because binder content with rubber mixes tends to vary a little more, and I think the ignition ovens aren't 100% consistent on it, but that's just an observation. Bonus was achieved for pretty much all the sections for binder and ride. Okay, so because this is a research project, we did binder and mix testing. Now, for the binder testing, we ran for the mix testing, we ran Hamburg wheel tracking testing, and then we ran massacre tests on the extracted binder. Now, I'm not saying we expect this mix to rut. Don't get me wrong. It's hot mix asphalt. What do you test it for? Since we felt all three ultra-thin bonded overlay mixtures were very similar in gradation, this was a real opportunity for us to test how the liquids were going to perform. So you can see the Hamburg tests over here. The control had a 4.28 inch rut. I'm sorry, 4.28 millimeter rut, 4 inches. That's nothing. Our cutoff is, on a conventional mix, is a 1/2 inch. But you can see that the asphalt rubber and the polymer modified mix had 2.6 to 2.7. So the most prone to movement of the aggregate, or the softest binder, was the straight 6428. We also ran massacre testing, and it's basically, I'm just looking at the black. The black is the JNR, which is the non-recoverable creep compliance. And you can see that the most prone to rutting should be the control, and the least prone to rutting should be the polymer modified. And the asphalt rubber, it showed, in the middle. This is with an extracted binder. I don't think you should be, I'm not sure if you should be extracting binders with asphalt rubber mixes, because I don't know what happens with the trichlorides in the rubber. But pretty much between the control, the standard binder and the polymer binder, we kind of saw what we expected. All right, more testing. We, 5 minutes. That's good because I think I have 5 slides. Okay, so we did some low temperature cracking and some intermediate temperature cracking. The low temperature cracking was a DCT. And what we saw with the low temperature cracking was that the asphalt rubber performed the best for the low temperature cracking, and the control and the polymer modified were pretty similar. And this is short-term aged, this is long-term aged. You can see that the asphalt rubber seemed to do pretty well for low temperature cracking.